Welcome to Lesson 10 of iptables Mastery. Iptables turns 25 this year, and the kernel developers built its successor, nftables. The good news? Same netfilter engine underneath, so your mental model survives. What changes is the user space tool. Cleaner syntax, native sets and maps, atomic config files. Think of this lesson as a bridge. Keep what you learned. Just learn the new way to express it. Here's the roadmap. 4 ideas frame this lesson. First, what stays the same? Tables, chains, hooks, contract, NAT, logging. Every concept ports over untouched. Second, one unified tool. NFT replaces iptables, IP6 tables, EB tables, ARP tables, and ipset with an enet family that handles v4 and v6 in a single rule. Third, native sets and maps. No more 50-rule chains or bolted-on ipset. Sets are first class, evaluated in log n time. And fourth, atomic config files. NFT loads the whole rule set in one transaction, all or nothing. So let's anchor that with a side-by-side. Listing all rules, iptables-L becomes NFT list rule set. Listing one chain, adding an SSH allow, deleting by index, flushing. Every verb you already type has a direct counterpart. Notice the pattern. NFT is more explicit. You name the family, the table, the chain, but the operation is identical. Save and restore even map cleanly to redirecting list rule set and NFT-F. Same job, 2 syntaxes. Now look at the config file itself, and the shift becomes obvious. An iptables save dump is just a flat replay of commands. An NFT config is a structured document. Table wraps chains, chains wrap rules, braces and indentation do the work. You get inline comments, sets like the curly brace deport list for 80 and 443, and even include directives. It reads like code you'd review, not a shell history you'd grep through. That structural thinking pays off immediately when you hit data. Blocking 5 IPs and IP tables means 5 rules. Scale that to 1,000, and you've got a linear lookup dragging every packet down. Or you bolt on ipset, which is a whole separate tool with its own syntax. nftables just bakes it in. Declare a set, list your addresses, then one rule references it with a blocked as ips. Hash-backed lookup, and you can add elements at runtime without reloading anything. Same job, native primitives. Now, you don't have to rewrite everything by hand. The kernel ships iptables translate, which takes an iptables command and prints the NFT equivalent. There's also iptables restore translate for converting an entire saved rule set in one shot. Just don't trust the output blindly. The translation is mechanical, not idiomatic, so review the file, apply it with a rollback timer, and expect to clean up by hand where it counts. So which path do you actually take? If you've got a working production firewall, leave it alone. Migration risk outweighs the payoff until you need a feature only NFT gives you. Greenfield project? Start on nftables, no reason to inherit legacy syntax. And if you're managing a mixed fleet, just accept it. Learn both, prefer NFT for new chains, and treat coexistence as the normal state of the world. Now the deeper question, why a whole new tool instead of iptables v2? 3 structural reasons. First, lookups. Iptables walks rules top-down, so 10,000 rules means a 10,000-step search per packet. nftables uses hash-based sets and maps, turning that into a log n lookup. Second, fragmentation. Iptables, IP6tables, ARPtables, EBtables, ipset, each with its own syntax. nftables collapses all of that into one tool. And third, atomicity. Iptables. Restore bolted it on later. nftables was designed around atomic transactions from day one. All or nothing rule loads, no race windows. That's the kind of fix you can't retrofit. So here's your printable cheat sheet. The NFT commands you'll actually reach for. 3 columns, 3 modes of work. On the left, inspection. List the full rule set, a single table, a chain, or a set. Add the -A flag when you need handles for surgical edits. The middle column is where you mutate state. adding, inserting at position 0, deleting by handle, flushing a chain. And on the right, persistence. Dump your live rule set to a file, load it atomically with nftf, dry run with C before committing, and let system bring it up at boot. Pin this one above your desk. Time to put hands on keys. 3 drills, all in your VM with a rollback timer running. First, translate. Dump your live iptables rule set and feed it through iptables restore translate. Open both files side by side and just read, don't apply. Second, write a small NFT config from scratch. Init filter table, drop policy, the usual contract accepts, loopback, SSH from your Office subnet. Third, build a dynamic set for a block list and add an element at runtime without reloading. Translate, write, mutate. That's the muscle memory you need. Before you ship any of this, know the landmines. Don't run iptables and nftables side by side. They share the same net filter core, and you'll get double filtering or silent gaps. Flush one before you commit to the other. Treat iptables translate output as a draft, not a deliverable. Refactor it into sets and maps. Use the inet family so one rule covers v4 and v6. Always dry run with nftc before nftf, or you'll lock yourself out. And check iptables v first. On RHEL 8 or Debian 11, you're already on nftables under the hood. So that's lesson 10. Same engine underneath, cleaner syntax on top, sets and maps as first-class citizens, atomic reloads by default, and one rule covering both address families. Your mental model from the first 9 lessons still holds. You just type it differently now. Next up, lesson 11. 4 real-world configurations. Web server, Bastion, Docker host, Kubernetes node, production-ready recipes you can lift straight into your own setup. See you there.